Hi everyone, I am here with second part of the chapter Boolean Algebra. In previous part we have studied about various propositional connectives and terminology that we will use in Boolean Algebra. Now we will explore some more topics from this chapter. First we will discuss about converse, inverse and contrapositive. Student, one question will be there in exam to write converse, inverse or contrapositive for a given conditional. First we will talk about converse. Converse of a conditional is obtained by interchanging antecedent and consequent. Now in this example you can see for the conditional, if P then Q or P implies that Q, here P is the antecedent and Q is the consequent. So the converse will be by interchanging both. That means now Q become antecedent and P become consequent. So here the answer, if Q then P or Q implies that P. Now we will see inverse. Inverse of a conditional is obtained by negating both antecedent and consequent. We simply need to negate both antecedent and consequent. Here you can see that example. For the conditional, if P then Q or P implies that Q, inverse will be simply not P then Q not Q, or not P implies that not Q. Simply we need to negate both the antecedent and consequent. Now the third one is contrapositive. Contrapositive of a conditional is obtained by getting inverse of the converse or vice versa. In both the way you will get the same answer. First you will find the converse of that conditional, then after getting its inverse you will get contrapositive. Now you can see in this example, if P then Q or P implies that Q, same conditional we are using, contrapositive will be if not Q then not P, or not Q implies that not P. You can see simple, it is just the converse of inverse, or in another term you can say it is the inverse of that converse. So these are three terms: converse, inverse and contrapositive. Now we'll move to the next topic, that is principle of duality. Principle of duality states that from a given Boolean expression we can obtain another Boolean expression by replacing each plus sign with each dot and vice versa. That means each dot with each plus. Similarly, each one with 0 and vice versa. Now we will see one example. For the Boolean expression a plus a dot b equals to a, its dual will be a dot in bracket a plus b equals to a. You can see in place of plus, dot is there in its dual, and in place of dot, plus is there. We will take another example. For the expression a plus a complement equals to 1, plus will change to dot and 1 will change to 0. Students, you can see complement we will not change. So just you need to remember only these two things, कि plus will change to dot and vice versa, and 1 will change to 0 and vice versa. That is the principle of duality. Now we'll move to next topic, that is basic postulates. These are very basic things. First one, if x equals to 0 then x not equals to 1, and if x equals to 1 then x not equals to 0. Second postulate, simple OR relation, we have already seen in OR connective. If any of the input is 1, output will be 1. You can see these four results. Similarly for AND relation, if any of the input is 0, output will be 0. Fourth postulate says complement rules. That means if x equals to 0 then x complement equals to 1, and if x equals to 1, then x complement will be 0. So these are the 4 postulates in Boolean algebra. Now we'll talk about some Boolean laws. Here are some propositional laws. First one is properties of 0. Student, you can see when we add 0 to a variable, we will get variable only, and when we multiply this 0 with a variable, we will get 0 only. Students, you can see every second law is simply the dual of the first one. Now second is properties of 1. When we add 1 to a variable, we always get 1, and when we multiply 1 with a variable, we always get that variable. Third is idempotent law, that states a plus a equals to a dot a equals to a. Next is involution law, that is a double complement will be that variable only. Then commutative law, a plus b equals to b plus a dot b equals to b dot a. Associative, when we have 3 variables, so we can arrange them in any order. Absorption, a plus a dot b is equals to a, and its dual a dot a plus b equals to a. Then complementarity law, that is very important, a plus a complement equals to 1, a dot a complement equals to 0. Then we move to distributive law. There are 3 distributive laws. First one we are very much aware in general mathematics also, a dot b plus c. We simply distribute that a to b and c as a dot b plus a dot c. Second is the dual of first one. You can see simply dot is changes to plus, and plus changes to dot. So it is a plus b dot c equals to a plus b dot a plus c. Third distributive law is a plus a complement dot b is equals to a plus b. Then De Morgan's law, that is a plus b whole complement equals to a complement dot b complement. Second is ab whole complement is equals to a complement plus b complement. We can understand its simple form, that break the line, change the sign. Here the line is the complement. Now next is conditional elimination. Sometimes we require to eliminate this implicit symbol, so that is equivalent to a complement plus b. Similarly, we can remove this by conditional also. So in 3 ways we can remove it. You can see the first, we can write it as a implies that b dot b implies that a. Second, a complement plus b, a plus b complement, and either a complement b complement plus ab. Now out of these we will discuss those are asked generally in examination in detail. First one is absorption law, which states a plus a dot b equals to a. Its second is a dot a plus b equals to a. We can see the proving using truth table. Here we have taken 2 input variables a and b. Now when we observe first and last column representing LHS and first column is RHS, both the columns are identical, hence it is proved. Similarly, second one we can see first and last columns are identical. Next is complementarity law, that is a plus a complement equals to 1, a dot a complement equals to 0. Again using truth table we can see a plus a complement column giving you only 1, as in input combination we are getting at least one true value. Similarly, for next second one we are getting only 0, hence it is proved. Then we talk about distributive laws. So we'll see first distributive law, that is a dot in bracket b plus c can be written as a dot b plus a dot c. When we see the truth table, so you can observe fifth column and the last column are identical. Fifth column representing LHS, last column represents RHS. Hence it is proved. Second distributive law, a plus b dot c equals to a plus b dot a plus c, and its truth table. Again you can see the fifth column and the last column are identical. Then third distributive law, that is a plus a complement dot b equals to a plus b, and in truth table last two column, second last column represents LHS and last column represents RHS, and again you can see both the columns are identical, hence it is proved. Now next is De Morgan's law, that states a plus b whole complement equals to a complement dot b complement, and a dot b whole complement equals to a complement plus b complement, and we can see the proving through truth table. You can see the last two columns in both the tables are identical, hence it is proved. Now the next topic is syllogism. The logical process of finding conclusions from given propositions is called syllogism. The propositions used to draw conclusion are called the premises. We can use following two methods to draw conclusion. First is truth table method and second is algebraic method. Now we will discuss them one by one. First we take truth table method. For this we have taken one example of modus ponens rule that states from premises P and P implies that Q, infer Q. We can also write it as, you can see there. Now for the solution, in this method we prepare a conditional whose antecedent is the conjunction of all the given premises and consequent is the conclusion to be drawn. If the conditional results in a tautology, that means output column having only ones, then the conclusion is established. Now for that given question, you can see two premises are there, P and P implies that Q. So that's why conditional will be antecedent we have taken conjunction of P and P implies that Q, and consequent we have taken Q. Now for this conditional we will prepare truth table. This is the truth table, you can see. Now when P implies that Q, we all know कि for conditional gives you 0 when antecedent is 1 and consequent is 0. Now in third row combination you can see P is 1 and Q is 0. That's why P implies that Q is 0. For rest of combination we can write 1. Now we see conjunction of both. For conjunction we all know कि if any of the input is 0, output will be 0. That's why for first three rows we are writing 0 and for the last row we are writing 1. Now we take conditional for the fourth column and second column. Fourth column acting as antecedent and second column as consequent. So we'll try to find any such combination where antecedent is 1 and consequent is 0. There is no such combination. That's why in output column we will write only once. Hence it is a tautology. So that is established. Now for algebraic method we are taking another example of chain rule that states from premises P implies that Q and Q implies that R, infer P implies that R. You can also write it as in this form. Now for solution we prepare a conditional like in previous truth table method. Then using Boolean laws we check if the conditional results 1, then the conclusion is established. Now according to this question the conditional will be like this, as two premises are there, P implies that Q and Q implies that R. So that's their conjunction is as antecedent and infer the conclusion is as consequent. Now we start proving. So first we use conditional elimination. That means we can remove this implies that symbol, as A implies that B can be written as A naught plus B. In this example you can see P implies that Q can be written as P naught plus Q. Q implies that R can be written as not Q plus R, then whole bracket complement plus not P plus R. Then we use De Morgan's. We have to simply distribute that whole complement of a square bracket to inner terms by changing their sign. So that's why it can be written as P complement plus Q whole complement plus Q complement plus R whole complement plus P complement plus R. We can further apply De Morgan's to break inner brackets. So now it can be written as P double complement dot Q complement plus Q double complement dot R complement plus P complement plus R. Now using involution law that states A double complement is equals to A. P complement can be written as P and Q complement becomes Q. Then we need to rearrange them using commutative law. Then we apply third distributive law that states A plus A complement dot B is equals to A plus B. Here you can see in previous statement P complement plus P dot Q complement, that will give you P complement plus Q complement, and R plus Q R complement will give you R plus Q. Now in this statement we can see Q complement plus Q is there. That means we can apply complementarity law that states A plus A complement equals to 1. Hence that Q complement plus Q will be 1. So it will be like P complement plus R plus 1. At last, using property of 1 that states that when we add 1 to any expression we will always get 1. Now as we get the result 1, this conclusion is established. Students, that's all for today. For rest topic we will discuss those in next part. Thanks.